Let's now discuss how we go about using the quotient rule to expand terms. The quotient rule can be used to rewrite a logarithm, and then converting this expression to exponential form can simplify it. So let's say we had the log of base 3 of 9 divided by 27. Since we are dividing two numbers in our argument here, we can use the quotient rule to separate this argument into the difference of two logarithmic terms. And then once we have these individual terms, we can simplify each of these terms further by converting each logarithm to exponential form. So this will allow us to take a logarithmic term and simplify it to a numerical value. So let's start at the beginning and walk our way through. Let's say you were asked to expand and simplify, if possible, the log of base 3 of 9 divided by 27. So this is the example we were just looking at. So step 1, we want to separate the argument by subtracting the log of the denominator, which is 27, from the log of the numerator, which is 9. So we take the log of base 3 of 9 and subtract the log of base 3 of 27. So the numerator goes first, the denominator goes second, and the log of base 3 of 9 can be simplified further, as well as the log of base 3 of 27. So we can convert each logarithm to exponential form. So we'll begin with the log of base 3 of 9. So we want to set that term equal to y, and then we can convert it to exponential form by taking our base 3, raising it to a power of y, and setting that equal to 9. And 9 is equivalent to 3 squared, showing us that y is equal to 2, letting us know the log of base 3 of 9 is equal to 2. So we can replace this term here with its equivalent value 2. And now the second term, we set it equal to y. And we convert this to exponential form by taking our base 3, raising it to a power of y, and setting that equal to the argument 27. And 27 is equivalent to 3 to a power of 3. And this allows us to see that y is equal to 3, letting us know that the log of base 3 of 27 is equal to 3. So we can replace this term here with its equivalent value 3. So we find that the log of base 3 of 9 divided by 27 is equal to the log of base 3 of 9 minus the log of base 3 of 27, which is equal to 2 minus 3. And now we can evaluate the expression 2 minus 3, and that gives us negative 1. So the log of base 3 of 9 divided by 27 is equal to negative 1. And that is how we go about using the quotient rule to expand terms. Let's now have you try a few practice questions. Expand and simplify if possible. Question number 1. The log of base 2 of 4 divided by 8. Question number 2. The log of base 4 of 16 divided by 256. And question number 3. The log of base 3 of 9x divided by 81. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. We are given the log of base 2 of 4 divided by 8. So step 1, separate the argument by subtracting the log of the denominator 8 from the log of the numerator 4, giving us the log of base 2 of 4 minus the log of base 2 of 8. And the log of base 2 of 4 can be simplified further, as well as this term, the log of base 2 of 8. So we want to convert each logarithm to exponential form and then solve for its y. So we'll begin with this term, the log of base 2 of 4. We'll set that equal to y, allowing us to convert it to exponential form by taking our base 2, raising it to a power of y, and setting that equal to the argument 4. And 4 is equal to 2 squared. So we see that y is equal to 2, letting us know that the log of base 2 of 4 is equal to 2. So we can replace this term here with 2. And now we can convert the log of base 2 of 8 to exponential form. So we set it equal to y. And now we take our base 2, raise it to a power of y, and set that equal to the argument 8. And we can solve for y now. We can replace 8 with its equivalent 2 cubed, showing us that y is equal to 3, letting us know that the log of base 2 of 8 is equal to 3. So we can replace the second logarithmic term with 3. So we find that the log of base 2 of 4 divided by 8 is equal to the log of base 2 of 4 minus the log of base 2 of 8, and that's equal to 2 minus 3. And if we evaluate the expression 2 minus 3, we find that this is equal to negative 1. So that is the answer to question number 1. Let's now have a look at question number 2. We are given the log of base 4 of 16 divided by 256. So step 1, we separate the argument by subtracting the log of the denominator, 256, from the log of the numerator, 16, giving us the log of base 4 of 16 minus the log of base 4 of 256. And each of these terms can be simplified further. So we want to convert each logarithm to exponential form and then solve for y. So we'll start with the first term. We'll set it equal to y, giving us the log of base 4 of 16 is equal to y. And we convert it to exponential form by taking our base 4, raising it to a power of y, and setting that equal to 16. 16 is equivalent to 4 squared. So this shows us that y is equal to 2 here. So the log of base 4 of 16 is equal to 2. So we can replace this term with its equivalent value 2. And now we change this logarithm to exponential form. So we set it equal to y. And now we convert it by taking the base 4, raising it to a power of y, and setting that equal to 256. 256 is equivalent to 4 raised to a power of 4, showing us that y is equal to 4 here. So we can replace this term with its equivalent value 4. So we find that the log of base 4 of 16 divided by 256 is equal to the log of base 4 of 16 minus the log of base 4 of 256, which is equal to 2 minus 4. And now we can evaluate the expression 2 minus 4, showing us that this equals negative 2. So that is the answer to question number 2. Let's now have a look at question number 3. We're given the log of base 3 of 9x divided by 81. Step 1, separate the argument by subtracting the log of the denominator, 81, from the log of the numerator, 9x, leaving us with the log of base 3 of 9x minus the log of base 3 of 81. This argument here, 9x, we are multiplying 9 times x, so we can use the product rule to separate this argument. So we want to take the log of base 3 of 9x and separate it into two logarithms. The log of base 3 of 9 plus the log of base 3 of x. So that gives us the log of base 3 of x plus the log of base 3 of 9 minus the log of base 3 of 81. And now step 3, we can convert each logarithm with a numerical argument, which is this term here and this term here, to exponential form. So starting with this term, we'll set it equal to y. And we can convert it to exponential form by taking our base 3, raising it to a power of y, and setting that equal to the argument 9. And we solve for y by taking this 9 and changing it to its equivalent, 3 squared, showing us that y is equal to 2, which lets us know that the log of base 3 of 9 is equal to 2. So we can replace this with its equivalent value 2. And now for this term, we set it equal to y. And we can convert it to exponential form by taking our base 3, raising it to a power of y, and setting it equal to the argument 81. And we can now solve for y. We replace 81 with its equivalent value, 3 to a power of 4. And this allows us to see that y would be equal to 4. So that lets us know that this is 4. So the log of base 3 of 81 can be swapped out for its equivalent value 4. And now we can evaluate the expression. So that gives us the log of base 3 of x plus 2 minus 4. 2 minus 4 is equal to negative 2. So we find that the log of base 3 of 9x divided by 81 is equal to the log of base 3 of x minus 2.